Power is the rate at which work is done. Here we have some variations of equations, any one of which we can use to calculate power. Power is work divided by time. Work is force times distance. So work divided by time could also be rewritten force times distance divided by time. And if we look at this distance divided by time portion right there, distance divided by time is speed. So the last version of the power equation is force times speed. The unit for power is the watt, symbolized by capital W. I do want to point out that we need to be a little bit careful here because there are two capital W's in what we see on the screen right now. We have one capital W, which is the symbol for the quantity work, and the unit for work is joules. Then we have another capital W, which is the unit for power, watts. So just be careful, there are two capital W's and they have different meanings. So let's do a problem. We have a flooded basement that contains 1.2 times 10 to the 8th kilograms of water that must be pumped upwards 2.5 meters. Presumably we have to pump it upwards and expel it out into the backyard. In what time would a 373 kilowatt pump empty the basement? Essentially what we have to do here is we have to lift this water up a distance 2.5 meters. We need to exert a force on that water to lift it upwards, and the force that we need to exert on it is essentially the weight of that water. So I'm going to use the F times D divided by T version of power, and the force that the pump is going to have to exert is essentially equal to the weight of that water. So I'm going to now solve this expression for time, and I'm going to put the variables in that we know. There's the mass of the water, there's G, there's the distance we have to lift it, and notice in the denominator I've taken the prefix kilo out and put the power of 10 in, because we don't want to put kilowatts into our equation, we want watts. So I've taken the kilo out and put times 10 to the third in. Type that into your calculator and you get 7,900 seconds, which is the right answer. But if we were trying to communicate this to someone, we might want to convert it into a unit that we would understand a little bit better. If someone asks you how long is it going to take to do something and you say, oh, about 7,900 seconds, that's not going to bode very well for you. So 2.2 hours, as we know there are 3,600 seconds in 1 hour. Let's try another one. An 85 kilogram mass, you can see it in this diagram, is this trapezoid here, must be raised to a height of 4.5 meters. Person A does so in 1 minute 24 seconds. Person B does so in 2 minutes 48 seconds. Find the work and the power done by A and by B. So let's find the work that's done by person A. The work done by person A is the force that person A will have to exert multiplied by the distance through which that force acts. Well, to lift this mass at a constant speed, person A will have to exert a force equal to the weight of that mass. So we can calculate the work done as 85 kilograms times 9.81 meters per second squared times 4.5 meters. If we type that out, that actually comes out to be something like 3,752 joules. But to two significant figures, I'm going to report it as 3.8 times 10 to the third joules, or 3,800. When I calculate the power expended by person A, that takes into account how long it takes for person A to do a certain amount of work. You'll notice that I've used the actual value of the work that I calculated above, 3752, rather than my rounded value of 3.8 times 10 to the third, because I want the best possible answer that I can get for power. I don't want to use a rounded answer in calculating the next quantity, because then my next quantity will be even more off than it otherwise would be. We also want to be careful here to make sure that we properly convert 1 minute 24 seconds into seconds. 1 minute 24 seconds is not 124 seconds. It's 84 seconds because there are 60 seconds in 1 minute. So be careful there. Again, rounded to two significant figures and using the correct unit for power, 45 watts. Again, note that there are two capital W's here. There's capital W for the unit for power, which is watt, but then there's a different capital W for the symbol for work, which is measured in joules, so just be careful of that. Person B exerts the same force through the same distance, and therefore does the same work as person A. But the power expended by person B is going to be different, because person B takes twice as long to do the same amount of work. Here we've converted 2 minutes 48 seconds into just seconds, because by definition a watt is a joule per second, and rounded to two significant figures, that's 22 watts. Power is the rate at which work is done, or energy is consumed. With this equation, be aware that there are two capital W's. One is the symbol for the quantity work, which is measured in joules, and the other is the abbreviation for the unit of power, the watt. 1 watt is 1 joule of work done, or energy consumed, per second.